Hello, in this video, I will explain to you on how to find I0 using mass current method, right? So our goal here is to find out I0. However, we need to use mass current method. Okay, mass current method, or some other books call it loop analysis and some other books call it mass analysis or loop analysis, but it is essentially the same. We need to use loops in the circuit. And so the first step that we need to do is to label all the loops, right? Because it is mass current method. So we need to label all the loops. Okay, let's see here. And also, aside from labeling all the loops, we also need to extract some information from the circuit, right? So we will have this first big loop here, and let's name this loop as I1. Okay, a clockwise loop here. I usually do clockwise because I am right-handed, right? If you are left-handed, probably you are more comfortable drawing counterclockwise. It is not a problem. Okay, and then this one here, I will have the second loop here as I2. Okay, and then I will have our third loop here, and I will name this as I3. Okay, but then we can also extract some more information here. And remember that we are looking for I0. What is I0? Okay, the current that goes to the same direction as I0 is I3. So we'll have I0 is equal to I3. But then here I2 is flowing to the opposite direction, right? Here I3 is flowing to the right, I2 is flowing to the left. So I will have I3 minus I2. So if we can get I3 and I2, we can get I0, right? And that will be our goal. Okay, I think we have done labeling all the nodes and also extracting some information. Now let's do the second step, which is to do KVL for each loops. Remember, for nodal analysis, we do KCL, but for mass current method, we do KVL, right? The Kirchhoff voltage law. Now let's do the first KVL here at loop I1. So let's do KVL at loop I1. Okay, and KVL said that the sum of the voltage in a loop will equal to 0. And we have to be careful about the sign when doing KVL. Okay, let's see here. I1 is flowing clockwise like this, and so the current when pass through this 80 volt voltage source will enter from the negative terminal. That means that our sign will be negative here. So I'll have minus, and then the value is 80, and we have already in voltage, right? So that is not a problem. So I will have minus 80. Good. And that is our first component. Okay. And but here, let's move on to this 5 ohm resistor. So I'll have 5. However, 5 is a resistance. To get voltage, we need to multiply it by the current, right? And currently, we are working on I1. I1 always came first. So I will have 5 multiplied by I1. However, here, I2 is flowing to the opposite direction, right? I1 here is flowing like this. I2 is flowing like that. So I will have I1 minus I2. Good. And then I will have plus, I think I will have this 70 ohm resistor, right? And again, we always write I1 first. So 70 multiplied by I1. Okay, but here I3 is flowing to the opposite direction. So I have minus I3. All of that will equal to 0. Okay, let's do some math here. 5 plus 70, I think that will be 75. Okay, and then 75 I1. Okay, I2 only comes from this place, so I'll have minus 5 I2. Good. And then I3 only came from this place, so I'll have minus 70 I3. And all of that will equal to 80. Okay, and I think nothing more that we can do from here. Let's save this as equation number 1. Good, now let's do another KVL, but this time at I2. Let's do KVL at loop I2. Okay, KVL said that the sum of the voltage in a loop will equal to 0. Okay, let's see I2 here. I will have 5 ohm resistor here. Okay, but different from the last step, here we are working on I2. So here I2 came first. So I'll have 5 I2. But then I1 is flowing to the opposite direction. So I'll have minus I1. Good. And also we have this 5 ohm resistor. So we'll have plus 5. The only current that passed through it is I2. So we'll have 5 I2. Simple. And then this one will be 10 ohm. Okay. So I will have 10. Again, we work on I2. So I will have I2 came first. But here I3 is flowing to the opposite direction. I will have minus I3. All of that will equal to 0. And then let's do some math here. I will have minus 5I1. Okay, and then I will have 5 plus 5 plus 10. That will be 20. So I have plus 20I2. Okay, and then finally we will have minus 10I3. Okay, all of that will equal to 0. Let's save this as equation number 2. Good. And let's do the last KVL, which is on I3. Okay, let's do KVL at loop I3. Again, KVL said that the sum of the voltage is equal to 0. I think I need some line for separator like this, so we don't get confused about which calculation is which. Okay, let's see here. The first component here, I will work on this 70 ohm. Okay, but here we are working on I3, so I3 came first. But then I1 flowing to the opposite direction. So I'll have minus I1. Good. Now let's move on to that 10 ohm resistor. Okay, this time I3 came first. But then I2 flowing to the opposite direction. So I'll have minus I2. And then I will have plus. I will have 12 ohm here. And the only current that passed through it is I3. All of that will equal to 0, right? Good. And then what can we do from here? Let's do some math. I1 only came from here, so I will have minus 70 I1. Okay, I2 only came from here. I will have minus 10 I2. And then 70 plus 10, I will have 80. 80 plus 12, I will have 92. Okay, 92 I3. And all of that will equal to 0. Okay, let's have this as equation number 3. Good. Now we have 1, 2, and 3. 3 equations, but with 3 variables, I1, I2, and I3. So what we need to do next is the third step, which is to solve the equation, right? Solve the equation. Okay, and I think the fastest way to do it is by using calculator, right? Because usually in circuit analysis, you can bring your calculator to the exam. So why not just use your calculators to do it, right? Okay, let's set this up here as calculator equation solver, which is number 5. And then 3 variables is number 2, and let's plug that in. I will have 75, and then minus 5, and then minus 70, and all of that will equal to 80. Good. And here I will have minus 5, and then 20, and then minus 10. And all of that will equal to 0. And then finally, for the third equation, I will have minus 70, and then minus 10, and then 92. Okay, and that will equal to 0. And so I will have our I1 here, which is 6 ampere. The X value is I1, right? So I'll have I1 is 6 ampere. And then what is I2? I2 is 4 ampere. 4 ampere. But then what is I3? I3 is 5 ampere, right? So I'll have 5 ampere. Good. But then the question is not asking us about I1, I2, on I3, but the question is asking us about I0. So the last step will be answer the question, right? Answer the questions. Okay, so what is I0? I0 is I3 minus I2, right? So I will have I0. What is I3? 5. And then what is I2? 4. 5 minus 4. And finally, we will have the final value of I0, which is 1. And the unit is in ampere, right? Because I2 and I3 both in ampere. And that is our final answer for this question, 1 ampere. Okay, thank you for watching. See you in the next video. Bye-bye.